Good morning, students. So in our last class, we discussed about the A inverse formula, is not it? So A inverse equal to what? 1 by determinant of A into adjoint of A. So now here, today we have to discuss one question, and this question is very important examination point of view. And if you see the question is here, so that the matrix A equal to 2, 3, 1, 2. So 2 by 2 matrix given here satisfies the equation. So the equation is given here, A square minus 4A plus I equals to 0. So where I is mentioned as a 2 by 2 identity matrix, as well as this 0 is mentioned as a 0 matrix. So here what you have to do, using this equation, with the help of this equation actually we have to find out A inverse. So if this type of equations are given to us, so here with the help of this equation we have to find out A inverse. Remember, if this equation is not given, then we have to apply the inverse formula, 1 by determinant of A into adjoint of A. But if the equation is given, then with the help of this equation we have to find out A inverse. So before this, first of all we have to verify this one, A square minus 4A plus I equals to 0 or not, is not it? So for that reason here, first of all you see we need A square. So here already A matrix is given, so that's why here already A matrix is given, is not it? So first of all what you have to do, we have to find out A square. So separately, if you find out the A square means we can write A into A. So here A means what? The matrix we have to write here 2, 3, 1, 2, is not it? So second matrix is same here, so that's why we write here 2, 3, 1, 2. Is it clear? Now if we multiply these two, so first row, first column, all of you know the matrix multiplication. So here we have to multiply the first row, first column. That means these two we have to multiply with 2. So that's why 2 into 2. So directly here we write 4. This one is, and the second element 3 into 1 plus of 3. So 4 plus 3 we get. Then here first row, second column, 2 into 3, that means 6, and 3 into 2, that means this one is also 6. Is it clear? Then second row, first column, so 1 into 2, that means 2, plus of 2 into 1, that means this one is also 2. As well as here 1 into 3, that means 3, 2 into 2, that means this one is 4. So this one is matrix multiplication. First row, first column, first row, second column. Similarly, second row, first column, second row, second column. All of you know this. So if you calculate this one, then what we get? 7. This one is 7. This one is 12. Here it is 4. And this one is 7. So A square result we get here. So A square equals to this one. So now next two are very easy here. 4A. So easily we can find out the 4A value. So without finding this 4A directly, if we write down the equation now here, so left hand side, so left hand side is here, equation is A square minus 4A and then plus of I means identity matrix of order 2. So A square result already we find out, this one we write 7, 12, 4, 7. So minus of 4A, can you tell me the 4A value? So 4A equal to what? 4, if you multiply this A matrix with 4, then the whole elements are, all the elements are we multiply with 4. So that means 4 to the 8. So the first one we write 8, and here 4 into 3, this one we write 12. Then here 4 into 1, 4, and the last one is 4 to the 8, this one we write. Plus of identity matrix, so that means we write 1, 0, 0, 1. You see. So if you calculate this one, these two we have to add first, and then we have to subtract with this result. So here you see 7 plus 1, 8, 8 minus 8, 0. Here we get 12 minus 12, 0. Then 4 minus 4, 0. 7 plus 1, 8, 8 minus 8, 0. So ultimately this result here we get what? 0, 0, 0, 0 matrix. So that means this one is 0 matrix. Which one is our? The right hand side, because here only 0 mentioned, that means it is what? 0 matrix. So this one equals to, we can write here right hand side. So the proof is very simple here, isn't it? So the next part is here important. With the help of this equation, how can we find out A inverse? So one thing we know, in case of A inverse, how can we find out A inverse? To finding the A inverse, first of all we have to identify the determinant value. If determinant is equally 0, then it is singular, then inverse we can't find out, is not it? So first of all we have to check out whether inverse exists or not. So in this case, first of all, now we have to find out the determinant. So determinant of A we have to find out. So in this case the elements are these here given 2, 3 and then 1, 2. So if we evaluate this one, 2 to the 4, So here we get this one is 4 minus 3. That means this one equals to 1, which one is not equal to 0. So if not equal to 0, then what we can say? Inverse exists here, isn't it? It is invertible, so we can find out the inverse. So now here, with the help of equation, we have to find out. So that's why first of all, you have to write down the equation. So a square minus of 4a plus of I equals to 0. Clear? So now in this case, what you have to do? Just you have to shift the identity matrix, or you can shift these two part also. So if we shift the identity matrix to the right hand side, so here what we get? This one we get here a square minus of 4a equals to this one we write minus of I. Clear? In this way you can write identity matrix. In this way you can find out, or you can shift this a square minus 4a also. Then here just I you have to keep on left hand side. Okay, now after that you see here, so we need a inverse. So what you have to do, since a inverse exists here, so you see here the constant term 4 is here. So what you have to do, by post multiplying by a inverse on both sides. So in bracket you have to write this one, then we get the value of a inverse. So this one is the process to finding the a inverse from a given equation. So what you have to do, post multiplying by a inverse on both sides. So because a inverse exists here, only for that reason we can multiply here. So in this case what we get, a square into a inverse post multiplying, minus 4a is already there, so we have to multiply it by a inverse, equals to, here we write minus I into a inverse. So post multiplying by a inverse on both sides. So now here you see a square means we can write a into a. So a into a into a inverse. Since we know one formula, one property we know, a into a inverse equal to what? Identity, isn't it? I into a inverse, what is the answer? We can write a inverse, isn't it? These properties are already we know. So here we can write this one is a into I. All of you understood this one? A square means we can write a into a, and 1a, if we multiply it, a inverse into a inverse equal to I. So that means a into I we can write. Minus, here you see a into a inverse. So a into a inverse means I. So that's why we write here 4i. And here minus of a inverse. Is it clear? Because I into a inverse equal to what? A inverse. So after that, now here you see, very simple. Now this one, a into I means this one we can write 4, and here minus of 4i equals to, this one is minus of a inverse. So after that, now easily you can find out this value, because a matrix is already we know a equal to how much? 2 3 1 2. So that's why in place of this one we write here 2 3 1 2 minus of 4i. So if we multiply 4 with identity matrix, this one is the identity matrix. If you multiply with 4, then what we write? 4 into 1, 4 4 0 0 0 and 4. So ultimately here we get this one is 4 0 0 4 equals to minus of a inverse. Is it clear? So now if we calculate this one, easily we can subtract this result, and after subtracting, what you have to do, we have to multiply it by minus on both sides to eliminate this minus, and then we get the a inverse result. All of you know, easily you can solve this part, isn't it? So in this way, using this equation, that means with the help of this equation, in this way we have to find out a inverse. So there we get two methods. One is the formula method, which one is a inverse equal to 1 by determinant of a into adjoint of a. So where only the matrix given, so with the help of this formula we can find out. And if the equation is given to us like in this way, in this equation, with the help of this equation, what you have to do, we have to find out inverse like in this way also. Is it clear? So here we get two methods. That's all for today. So in our next class we solve some more questions. Okay, thank you.